going to look at page 5 in the beginning of electromagnetic waves. So here they introduce us to the vector S. You may remember from the polarization lab that we used S for intensity, and they say here S gives you the intensity at any point. But the vector S is called the pointing vector, named after somebody, and so it's spelled like this. But the pointing vector points in the direction of E crossed with B, which is the direction that the wave is going in. So the pointing vector points in the direction that the wave is moving in. When you do E crossed with B, you'd get in this situation here, it'd be pointing in the I hat direction. And since these vectors E and B are always perpendicular to each other, you just get E times B for the magnitude, and the magnitude of the pointing vector is the intensity. This is the intensity at some moment in time, which isn't particularly useful. We would rather have the average intensity. So if you take our expression for E and B, which we had previously, and plug them in to what we have here, you end up with a cosine squared function. And I'm not sure that we did this. I'm pretty sure we didn't do it before, so let's take a look at this now. So if you look at cosine squared, if you had just the cosine function, it would look like this. And let's say that this is 1, this is -1. So if you square the cosine function, the maximum value that you have here is still going to be 1. Here, you square 0, and you still have 0. It's going to be something like that. And then if you square -1, you get 1. So your cosine square function is going to look something like this. And then, if I draw a line here at 1/2, everything that I have up here would fill in the missing area that I have down here. Or you could say the cosine squared function spends just as much time above this line as it does below this line. So, as they say, it's common knowledge that the average value of the cosine squared function is 1/2. So if you do the average intensity, this becomes 1/2, and that is our new equation. Also, remember, as we saw before, at any point, E divided by B is equal to C. So it must also be true because the electric field is at its maximum value and the magnetic field is at its maximum value. So we can say E max divided by B max is equal to C. So you can use that to write this just with the electric field. And so we have this expression here. Okay, and that is energy of electromagnetic waves. We are not going to be doing example problems with everything that is covered in the beginning of the electromagnetic wave section, but you should still read through everything here. So that would be up to page 17. So you should read through everything, but we may not actually do example problems for all the material there.